Welcome everyone, I am Tamika Lodge Fenton. Thanks for joining us for the City and Guilds Math and English sessions. We're going to start with math, and today we'll be focusing on shape and space and the use and interpretation of graphs, charts, and maps. So the first question, as you can see from the diagram, you have angles on a straight. Now, this diagram is not drawn accurately, however, you can see the degree of angles on both sides, and x is unknown. So you're asked to find the size of angle x. What information do you need to access this particular question? Yes, angles on a straight add up to 180. Now, if you have that information, you can pretty much use this to figure out what x is. So x is simply equal to the sum of those two angles subtracted from 180. And we can do that very easy. So 50 plus 65 gives us a total of 115 degrees. We subtract that 115 from 85, giving us 65 degrees. So angle x is 65 degrees. And if you were to add all three angles, you should get a sum of 180. Let's just check that. So we have 50 plus 65 plus 65. So here we go. 5 plus 5 gives us 10. Okay, 6 and 6, 12. 12 and 5, 17, and 1, 18. So the value of all those three angles give us a total of 180. Angles on a straight add up to 180. Next question, we're still doing angles. So as you can see here, the figure is not drawn to scale. Find the size of the reflex angle. Why? What is a reflex angle? Okay, great. An angle that measures more than 180 degrees. All right. So here we go. What do we do here? Angles at a point. This is very important information. Angles at a point add up to 360 degrees. Therefore, if we want to find angle y, we'll simply subtract that 65-degree angle from the 360, which would give us the reflex angle. And that gives us 295. So angle y is 295. That means 295 plus 65 would give us 360 degrees. All right, which one of these statements is true? First statement says an equilateral triangle always has a 60 degrees angle. Second one, an isosceles triangle always has 3 equal angles. Third, an equilateral triangle always has a 90 degrees angle. And then the last, an isosceles triangle is always an equilateral triangle. So we have to know about our triangles. So let's look at some information that we should know. What triangle is that? What triangle do you think that is representing? What about that one? All right, let's discuss. An isosceles triangle has 2 equal sides and 2 equal angles. Now, when you look at this diagram here, these 2 little markings on the sides indicate to us that those 2 sides are of the same length. They are equal. And then when you look at the angle with the same notation there, it also means that D and F are equal. So what we're saying, ED is equal to EF. Those are the sides. And angle D is equal to angle F. That's an isosceles triangle. Now let's look at the other one. An equilateral triangle has all equal sides and angles. So if you look at this one, you see the same mark on all 3 sides. That means all the sides are equal. And if you look, all the angles are 60 degrees. So I hope you have figured out which is the best response. So now a point to make. An equilateral triangle is an isosceles triangle, but not the other way around. So the statement here says an isosceles triangle is always an equilateral triangle. Not true. It is because the equilateral does have two equal sides and two equal angles, it can fit. It can be seen as an isosceles triangle, or it is an isosceles triangle, but it's not the other way. So the best statement for this is option A. An equilateral triangle always has 60 degrees angle because all its angles are 60 degrees. Therefore, option A. So we have the next question. These triangles are drawn to scale. Which two of the triangles could be equilateral? Now remember, we just examined what equilateral triangle is. They must have all the sides are equal, all the angles are equal. So it's pretty much observation that you're looking at now and making an intelligent judgment. So if you realize that A and C are equilateral triangle, you did great. Your observation skills is excellent. All right, so that would be option B. Which of these shapes is congruent? Now, the word congruent, we've spoken about it in previous lessons, but just to refresh your mind, what does congruent mean again? Yes, it pretty much means same. So, which of these two triangles or shapes, as the question has, are the same? All right, did you say A and C? I hope not. Well, it's shapes A and B. Now, why not C? So although they may look like they have the same orientation and it looks like they're all right angle triangle, this is the only one that doesn't look like a right angle triangle. C is not congruent to A, nor is it congruent to B, because the angles may be the same, but the sides are not. And when you talk about congruency, all the lengths of the sides and the angles must be the same. So the sides are different. So C is not congruent to the other two. All right, next question. Which of these shapes have the same perimeter? So, what is perimeter? All right, perimeter is the total length of the outline of the shape. So we're going to look at the length of the outline of the shape and we are going to figure out the perimeter. So let's go on the board. Yes. So I'm just going to quickly put up the diagrams to represent each option that you have. So if you're given the question, you pretty much go on to your paper and you sketch. Nobody can stop you from doing that. So the square, so it says a square. That doesn't look like a square, does it? So I'm just going to use A, B, C, D. I like organization, so all right. I'm going to use these to show that it's a square. So it's 4 centimeters here. That means all the other sides are 4 centimeters. I'm not going to write it anymore. Then it says a rectangle. So you know the rectangle. You have those two parallel sides there, or two longer sides and two shorter sides. You have 9 centimeters here, and you have 1 centimeter. Now, obviously, if it's a rectangle and this is 9, this is also 9. C says rectangle as well. All right, so I have an eraser, but I'm using my hand. So I have a rectangle again. The rectangle says 4 by 3. So I'm going to cut my rectangle down, 4 centimeters by 3 centimeters. And then my last one, rectangle, 6 by 2. So I have 2 here and I have 6 here. All right, so let's pretty much quickly do the perimeters. So if this is 4 all around, it will be 4 plus 4 plus 4 plus 4, or 4 multiplied by 4. And that would be 16 centimeters. Oh, perimeter. That's so wrong. I would have 4 by 4, yes. So it would be 4 centimeters multiplied by 4, giving me 16 centimeters, because perimeter is a linear quantity. It's not a squared quantity. All right, now 9 plus 9 is 18, 18 plus 1, 18 plus 2. So that would give me 20. Good. So this is 20 centimeters. Now this is 3, this is 4. So 4 and 4 is 8. 8 plus 6 is, what is that? All right, that's 7 and 7, 14. So it's 14 centimeters right there. And this is 6 plus 6, 12. 12 plus 2, 14. 14 plus that is 16. So the questions are pretty much you work out the perimeter. And you can look, observation, 16 and 16. So the options would be A and D. So D is your choice. All right, very well. Now, calculate the perimeter for this T-shaped flower bed. Now I want you to pay attention to all the parts that you have to consider when you look at this flower bed. So we're just going to do the diagram on the board to show you the parts that I want you to look at, but the calculation, we're going to do it on screen. So let's look at the T. Now you're given some of the lengths, but you're given all of the lengths, but you just have to deduce some. So here to here is 3 centimeters. Here to here is 11 centimeters. And you're also given here as 2 centimeters. Let's take all of this off the board. All right. And then we have here is 8. Now remember, the perimeter is all the distance, all the outline. Every length that you can see on the outline of the shape is its perimeter. So although you see no measurement here, you have to find that measurement. All right, so we know this is 2. So this is also 2. All right, this is 11. Straight across is 11. So if all of this is 11 and this is 3, we can take away 3 from 11, and that would give us 8. All right, so if this and this is the same length, and they both add up to 8, we can divide 8 by 2, gives us 4 on this side, 4 on this side. We also know that this is the same length as across there, so it's 8 there. So we have 1, 2, 3, 4, 5, 6, 7, 8 different lengths that we're adding. So let's do that now. So we have 11 centimeter plus 2 centimeter plus 2, and you can see them right here. And then we have 4 plus 4, 8 plus 8, and then we have plus 3. And that will give us 42 centimeters. So the perimeter for this T-shaped flower bed is 42 centimeters. All right. So the diagram shows a layer of tins in the base of a small box. And it's not drawn to scale, but you can see it right there. How many tins with a diameter of 7 centimeters will fit into one layer of the base of a large box, which measures 84 centimeters by 84 centimeters? So let us just give you a little insight into what you're doing. So, you know, I like diagrams, so you can always use your diagrams to help you understand a question. So we now have a box, a larger box. This side of the box is 84 centimeters, and this is also 84 centimeters. And we know this because I don't think I've ever seen a crooked box unless it's really shaped that way for a reason. But most boxes, the opposite side matches each other. So this is 84, this is 84. Good. It tells you that the diameter of the tin. What is a diameter? So if this is the center of the tin, there's a line going straight across the center of this circular base tin. And that is its diameter. So this is its diameter. And it says the diameter is 7 centimeters. So when I put the tin here, from this point to this point, it would take up 7 centimeters. So pretty much, I can now figure out how many 7 centimeters I can get across the 84 centimeter by division. So let's look at what happened here. So we're reasoning. So what do you know? The diameter of each tin is 7 centimeters, which we said that. The length of the box, we want to fit them in, is 84 by 84. We drew the box. Now, how many tins can hold along each side of the box? So 84 divided by 7 gives us 12. So pretty much, and I'm not drawing 12 tins, so we'd have 12 tins right here, right? Now this length is the same as this length. So therefore, I would also have 12 tins right here. Can't spell tins? Tins. Good. So I'd have 12 tins here, 12 tins here. So pretty much I could put 12, 12, 12. So 12 by 12 tins would give me a total of 144 tins in the box. All right? All right, so we're here at a volume question. The volume of a rectangular box with width 13 centimeter, length 25 centimeter, and depth 10 centimeters is, how do you find volume? So volume is a cubic quantity. And volume is calculated by multiplying the width by the length and also by the depth of that structure, that figure, that solid. So there we go. They have given us all the measures. All we have to do is multiply. 13 multiplied by 25 gives me 325 squared centimeter. Multiplied by 10 gives me 3,250 cubic centimeter. So the volume of that regular rectangular box is 3,250 cubic centimeters. All right, so we're here at a graph. We're going to look at this graph and see if we can answer the question. How many of these laptops were sold in June? So pretty much you have a key. Each laptop on the graph represents 200 laptops sold. So pretty much we can go through this. Pretty easy. January has 3 whole laptops and a half a laptop. So 200 for each whole plus the half, which is 100. That gives us 200, 400, 600, 700. So 700 laptops were sold in January. A health eating website recommends that people eat food in the following proportion. And you can look at the pie chart and just pick out some information there. What do you understand from this pie chart? According to this pie chart, let's see. This and this looks the same. It doesn't match anything else here. The options are more protein than carbohydrates. Look at the portion. The protein section is smaller than that of the carbohydrate. And if no fats and sugar, that's not true. They gave you a section for the fats and sugars, mainly milk and dairy. That's also not true because these sections would have been larger than the milk and dairy. So it can't be mainly that. So as much fruits and vegetables as carbohydrates because the portion is pretty much the same. All right, so that's all the time we have for today, guys.